Hello everyone, welcome to another video. So this is a video 2 for vectors, and today we're going to touch on two things. The condition for parallel vectors, as well as what this thing called a position vector is. So let's jump straight to it. So let's start with parallel vectors first. We can see that these two vectors are parallel. Visually you can see that's parallel. And then one is 4, 6, one is 2, 3. So in vectors, there's a way to actually tell whether two vectors are parallel. So I'm going to jump straight to the condition. You can see that it's written AB is equal to K times CD. So K is a certain number. So in this case, you can see that, so what it means is, if I can take this number, I times a certain number, I'm going to get this. Then these two are parallel vector. So, and the other way is fine also. So let's look at this. So I do it the other way, is easier, right? So for 2, 3, AB, is there a number I can times such that I'm going to get this? Now it's very obvious. If you times 2, you get 4, 6, which is exactly this. So the fact that you can times 2 to this vector and get this vector, that means these two vectors are parallel. So that's what the theory is. And another way to see this is, if I can factorize all the common factors in this vector out, and I do the same thing, eventually the leftover vector, if they are the same, they are also parallel. So for example, if I take out 4, 6, I can take out 2, right? So I'm left with 2, 3. This one is already simplest term. I can't take out anything anymore. So, but you can see that these two are the same. We call this a directional vector, but this is the A-level thing. So just remember that you can also do it this way. You can factorize everything out. So if the base vector is the same, they are also considered parallel. So let's see how this works in a typical question. So you see that we have these two vectors, and you are told that they are parallel, and then I need to find y. So what you do is, since they are parallel, I know that let's say this times something is going to give me this. So I write the 2 minus 3 here, and it's pretty obvious because 2 times 4 is going to get 8, right? So I know that the number is going to be 4 because 2 times 4 is equal to 8. And with the same theory, because they are parallel and I know they are parallel, 4 times minus 3, which is minus 12, is going to be equal to y. And that's why minus 12 is the answer. That's it. Okay, so let us continue. The next thing we're going to talk about is actually position vectors. So there's going to be a QR code here. This is what we call key skill 2. Absolutely crucial. This phrase here, AB is equal to OA minus OB, you're going to use it for nearly every single question. You must know how this thing comes about. So please go and watch this before we continue. Okay, we're going to continue with some other questions in the following. So this one is a parallelogram. So this parallelogram, I got R and S, so here, and then I need to express all these things in terms of R and S. So the first one is RT, so it's this one, is this direction going down. Now because this is parallelogram, you know that this is the same thing, because that's what parallelograms are, right? So if this direction downwards is S, this direction downward is obviously going to be S also. That's why S is the answer straight away. Okay, the next one, OT. So OT is here from here to here. This is where we can use the triangle rule. So you can see that this plus this is equal to this. That's why OT is equal to R plus S, because this is the R, this is the S, and the direction is all correct. That's why it's R plus S. Finish. So the last one will be RS. So RS is a bit more difficult. So RS is here, this direction, right? Pointing here. So again, we are using just this triangle only. I'm going to cover the useless thing. So here. Okay, so from this triangle, I just need, see, it's very hard to express this alone. So what I do is, I try to involve the RS in a so-called equation. So if I just follow the arrow, this plus this is equal to this. You see, this is the triangle rule and just the resultant vector concept. So I write down exactly this. So OR plus RS is equal to OS. So that's what I'm writing here. This R, which is OR here, plus RS here, is equal to S here. And then what I simply do is I make R as the subject. So this R needs to go to the right side, and that's the answer. Finished. So you can see that this position vector is very important because it helps you so-called break down the vectors, and then eventually you just make whatever you want to be the subject, and that's how you solve vector questions. Okay, so next one, we're going to look at this question. You can see that I give you two coordinates, 2 points, and then I need to express this PQ. Okay, again, they want position vector. So you know that in position vector, the coordinates is effectively the vector. So the first answer is 2, 3, these two numbers. The next answer is 4, 1. Okay, so it's basically the coordinates because they are position vectors. Next, I want to have PQ. So using our position vector theory, PQ is always Q minus P. That's why it's Q minus P, but you do in vectors, right? So it's Q minus P. So Q minus P equal to answer. That's it. So and then say a point A is this is the point translated by the vector 9, 6. So you can imagine that A is here, 5, 3, right? And then if I translate, I move it by this vector, which is 9 minus 6, I'm going to get B. So they ask you what is the what coordinates of B, right? So you can see that with this first point, A is already here. All I need to do is I need this vector plus this vector is equal to OB's vector. So this is obviously going to be 5 minus 5 and 3 because this is position vector here. Then so it's 5 minus 5, 3 plus this is going to be the vector of B. So I just plus together, I get 4 minus 3. So this 4 minus 3 is the position vector of B. Now I don't want position vector, I want coordinates. That's why I need to write it as 4 minus 3, not in this way. This is a vector, but I want a point of coordinates, so I must write 4 minus 3. Okay, so the next one is again I have 3 points, this, and then I need to express the following in column vector. So I want PQ. So with the position vector theory, it's going to be OQ minus OP. So it's this minus this. That's why it's write this in vectors minus equal to this. That's it. So for QR is the same thing. QR is R minus Q. So it's this minus this. That's why it is, you can see that it's 2, 3 minus 2 minus 4. And you just minus that. That's it. Okay, so now we're going to do something that's linked to parallel vectors. So they want to ask you all these 3 pairs, which pairs are actually parallel vectors. So the condition for parallel vectors is such that if you can take this times a number, you can get the other one, then they are parallel. But in this case, it's a bit hard to see because it's not very obvious. So what I do is I do it the other way. I factorize out whatever things I can for this and this. So you can see that, well, 6 minus 3 at right here. I realize I can take out 3, right? I'm going to take out 3. I'm left with 2 minus 1. So for the other one is minus 4, 2 right here. I'm trying to take out a common factor. So I choose to take out minus 2. And you can see that the resulting one is 2 minus 1. So see, these two are the same. And from there, you can conclude that these two are parallel. So in this case, it's the same trick. These 2 vectors, I'm going to write here. I take out 5, I take out 3. I realize the resulting things that's left is minus 1 and 3. So they are the same. So these 2 are parallel. So for this one, I'm going to try to do the same thing. For 16, 20, I'm going to take out 4. 6, 8, I'm going to take out, I can only take out 2. And realize that 1 is 4, 5, 1 is 3, 4. And they are not the same. These 2 are not the same. That's why they are not parallel. Okay. Yeah, so with this, we have come to the end of the first part, and we're going to start doing these two, the next part of vectors, which is basically just doing the long questions. There's really nothing else you need to learn. You have already learned everything in vectors. So now it's good time to do a homework 1, the first set of questions, followed by then you can start this part 2. Okay, so hope you learned something. Thank you and bye bye.